Okay, welcome in the IMTech Energy and Automation Laboratory. We are located here at Innovation Dock at the RDM Campus in Rotterdam. We have our own greenhouse where we have two spaces. One is at the other side of the wall where we develop some robotic boats, which we call aquabots, together with students of University of Rotterdam. And in this area, in this space, we have our own energy demonstrator, where we can do some testing for hybrid systems, testing the automation functionalities, and do some prototyping. We built this system partly in the INOMANS2HIP project, where we can test not only the INOMANS2HIP control strategy with simulation on the computer, but we can also test with some more real equipment, so that we get a better validation of the controllers. Our demonstrator consists of two parts, of three parts, let's call it. Two electrical parts. One is an AC system, which is more like a commonly used nowadays system. And on the other side we have a direct current system, DC system, and there is the automation part and the presentation part. We have four big screens where we can show everything what's happening on the hardware demonstrator. For INOMANS2HIP we have an extra computer where we're running the developed controller, the PSO. And we have there the platform simulation in gas running. This is the AC part, when we have some local controls, but also we can control the system from the central automation system. So in the AC system we can test different kinds of sources. So for example we can make like let's say a shore kind of connection, power connection, but also we have a small generator set where we can do some simulation of diesel generators or LNG generators. For example, I can start one. Now it's running. It's a real generator running right now. It's starting. It's really it's like how it works in the real world. You see it on the screen. You can see that it starts becoming green. Now the circuit breaker is closed and it's powering one part of the bus bar, the AC bus bar. And I can close bus time, but this one is now closed and the rest become green as well. So now we're supplying the demonstrator with a generator. There are also a possibility to put, for example, PV to it or other types of sources. So we can also do the control remotely on the automation system. Now we'll turn on the shore connection. We'll synchronize it when it's on. Now it's parallel with the generator. I will stop the generator. Generator is now stopped. We are still powering the system. Now the shore mode silent. Then we'll go to the DC system. On the DC system we have connected some batteries as well, so we can test some hybrid kind of systems. We have PTI, PTO, so we can have here two motors connected together on the shaft. And we can transfer the energy one side or the other side, so that it will be a generator or a motor. So we can make different kinds of installations. Start to run it. Now we can, for example, simulate with the demonstrator that this motor becomes a drive for a propeller. And this motor now works as loads, which simulates a propeller curve. So that energy is now supplied from here to there and back into the main grid. In the INOMANS2HIP, we all together developed, for example, a new way of controlling power systems, the energy management, to find the optimum way of operating the power plants. The controller that was developed, we can use that on real ships. So the controllers, for example, working here on a computer, we can reconfigure the controller for a certain ship, and we just can install it on the ship, and then there we have our controller for energy management. And in the INOMANS2HIP we also developed a new human-machine interface, which is more intuitive compared to the classical way of presenting things. So, for example, we have HMI, which is more like nowadays a mobile phone, smartphones or tablets way of controlling things. So it's just, you can control, for example, generators by just drag and dropping them into the system. For example, I can turn on the generator, turn off the generator, and put some batteries on. But the human-machine interface is not only for operating the system, but also tells you how the system performs. For example, we have here at this side a propeller, which is using too much power, for example, that becomes red, and the attention is made to that consumer that's not working fine. You can control it to make it more into its normal operation again. So for us, this is a very nice outcome of the INOMANS2HIP project. As IMTech, we are involved in the INOMANS2HIP project, and for us, it's a very interesting project for us to develop energy management systems and work together with a lot of partners, international partners, from universities, knowledge institutes, and other companies. All together, we have a lot of knowledge, and we have already made some quite nice results in the project. But, for example, we already saved about 10% in our reference ships. Which was only possible by working all together.